All right, to solve the inequality, 2x plus 6 is less than or equal to 4x plus 2. Again, my goal is to isolate the variable or get it on one side of the inequality by itself. So typically we like to keep the variable positive. So I'm going to subtract 2x from both sides, leaving my remaining 2x on the right side. So I have 6 is less than or equal to 2x plus 2. From here, again, I'm just going to isolate the variable. So I'll subtract 2 from both sides. I'm looking at 4 is less than or equal to 2x. Divide both sides by 2, and I get a final answer. 2 is less than or equal to x. So here is a good answer. Now, to graph this, seeing the variable on the right side is a little bit funky because I see that less than or equal to sign, and I'm thinking of shading to the left because that's usually all my numbers less than. However, we'll notice if the variable is on the right, I want to rewrite this so it's a little bit easier to graph. So I'm going to, instead of 2 is less than or equal to x, I'm going to rewrite it with the variable on the left side of the inequality. Now notice that this less than or equal to sign, it opens up to the x. So when I rewrite it, I need to maintain that consistency. So I'm going to actually have x is greater than or equal to 2. Because if 2 is less than or equal to x, that means x has to be greater than or bigger than or equal to 2. Either of these are fine solutions, but as far as graphing them, the second one is a much easier graph. So I'll put 2 here. I want all of the numbers that are greater than or equal to 2, which is to the right. That's 3 and 4 and 5, etc. And because it's or equal to, my circle on 2 is going to be shaded in because the solution set does include 2. Now, a reminder that in order to check, you can always substitute a variable or substitute a part of the solution back in. Oh wow, can't spell. Substitute a number that is part of the solution back in. So in this case, you could choose x equals 5, x equals 10, x equals 100, something that is greater than or equal to 2, substituted back into my original inequality to double check that I get a true statement and that I know that I solved this correctly.